Okay, we are going to do some problems here on problem 238, starting with number 10. The directions are basically solve for x and y. That would make these two triangles congruent by hypotenuse leg. And essentially, excuse me, the legs are congruent and the hypotenuses are congruent. And ultimately what this problem becomes is an algebra problem. So let's set up the equations here. First of all, we're going to say this leg, x, is equal to this leg here, y plus 1. And as soon as you have an x and a y, you know you're going to need two equations. And the other equation will be the hypotenuse is equal to the hypotenuse. X plus 3 is equal to 3y. Got to solve for both x and y. We're going to use substitution. These are systems of equations. I know x is equal to y plus 1, so I'll just substitute it in the other equation. And so instead of x, it is y plus 1 plus 3 is equal to 3y. Then we will solve for y here. 1 plus 3 is 4. 3 minus 1y is 2y. Divide by 2, y is equal to 2. And then, of course, use one of these equations to solve for x. I now know y is 2. So simply plug in a 2 there, and it looks like x is 3. So x is 3, y is 2. Okay, we're going to do problem number 25 here. It's a two-column proof. You just given some perpendicular lines and you've got an equilateral triangle. What makes this proof strange and different is the fact that we have a three-dimensional proof here. So we've got to be careful on what we're trying to prove. So if I look at this carefully, try to prove that triangle AEB. I will shade this triangle AEB. This is this triangle on the inside there. AEB is equal to triangle CEB. CEB. So the two inside triangles. Maybe I'll shade this one in yellow here. So we're going to try to figure out why those two triangles are equal, when in fact there are actually 5 triangles inside this three-dimensional figure. So you got to be aware of which ones we are trying to figure out. So I've already written out the given, and essentially I pulled out, even with the dash 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 lines, the two triangles, the shaded one and then this highlighted yellow one. And so of course we're going to figure out certain parts and certain angles to be equal. So step 2, since we mentioned that these lines are perpendicular, I'm going to mention that certain angles are 90-degree angles. So I'm going to say angle AEB, this one here, which is right here, and angle CEB are right angles. And the reason why they are right angles is because you mentioned there are perpendicular lines. So we're going to go definition of perpendicular lines. Perpendicular lines create right angles. Okay. The reason why I want to mention that there are right angles is because we want to say that these two triangles that we're trying to prove eventually, first we're going to mention that they are right triangles. So triangles AEB and CEB are right triangles. And of course the reason why they are right triangles is because step 2, they have a right angle in it. You can spell out because they have a right angle, they are right triangles. Or I'm just going to go definition of right triangles. So now that I've brought up the fact that they are right triangles, I can use hypotenuse leg. So let's see what we got here. Also in the given, right here, it says triangle ABC. This triangle in the front is equilateral, which of course means all sides are equal. So I could say AB is equal to BC. And I can also mention that it's also equal to AC, but this extra part here I don't really need. But I can say AB tick is equal to BC tick. AB tick, BC tick. And of course that is because that is the definition of equilateral triangles. The fact that all 3 sides are the same, but really I only need 2 of them. Equilateral triangles have congruent sides. So what I actually did, though, is find out when you go into the three-dimensional world, I've already figured out the hypotenuse. I'll put a little h there for hypotenuse. I need a leg. I've already mentioned that they're right triangles. I need a leg. Well, the leg is going to be BE is equal to BE, reflexive property. And if I look carefully at the picture, this is a B to E, this dashed line, tick, tick, which is right here. Once I separate the two triangles, tick, tick, I've got my two triangles share that same BE, BE. Now I'm going to go to the proof. The shaded triangle is equal to the yellow triangle. The AEB is equal to triangle CEB because of hypotenuse leg. Oh, by the way, this was the leg. Hypotenuse leg. So we got a basic two-column proof, but it's weird because it's in the three-dimensional world.